Recording in progress.
Great, thank you. Now we record these sessions in case somebody has to miss the session and then they can rewatch it. Or if maybe there's something you want to go back and rewatch and something you maybe didn't quite understand or you missed something, you can go back in that. So the recordings are uploaded to our learning management system, which Loretta's going to take you through shortly, and about 24 hours after the session. So if you have to miss a session, you'll be able to find it in there and watch it in your own time. Also, we just chuck in a little content warning. We do show some road crash scenes, nothing overly graphic, but we're just trying to learn what went wrong and try to prevent that in the future or lessen the severity of those incidents. So that's a little warning if that's something that could trigger you. Now, who are you, Loretta?
That's me. I'm a training coordinator at Safe System Solutions. So I'm working alongside a team who, I guess, moderate the courses and organise everything in the back end. You may have heard from my colleague Marissa. So Marissa and I are working together on this program. But if you can't make a session, if you're having any issues with anything, haven't received emails, please contact us, and our email is right there where the arrow points, training@safesystemsolutions.com.au.
Thank you. So make sure you do get in contact with Loretta for any admin management issues around the training course and access to the learning management system and anything like that. Now, a little bit of Zoom keeping.
So I guess just to cover, this is a webinar, so we can't see you or hear you. So we do encourage you to participate as much as you can through the session. So there's a chat function. So feel free to interact using the chat. You can raise your hand if you did want to actually talk, so we can allow you to talk if you wanted that option. And there's also a Q&A function. So use that to ask your questions as well. And with the chat, you can see the little red arrow pointing there. You can chat to everyone. It's probably best to chat to everyone because all questions are good questions. But if you did want to sort of, ask me or Ken something specific, maybe not related to everyone, feel free to change that. If anything fails, I know sometimes, when we're doing polls or things like that, or you might drop out. First thing you should always do is just leave the webinar and then log back in. That usually works. But otherwise, we do have the slides on the LMS, so the Learning Management System. There is a PDF there that you can upload and follow on if you can't see the screen for whatever reason, or you can dial in as well, which was on the emails. And then, of course, you can watch that recording later on.
Thank you, Loretta. And my name's Ken Beer, for those I don't know. I'm the Principal Engineer at Safe System Solutions. And my contact details are there, a little QR code to my LinkedIn. If you're not connected with me already, we do share quite a bit of road safety engineering and auditing content online. I like to try to keep industry up to speed on the latest through that forum, or that platform. Please connect with me. And my colleague, Sam Paisley, who's the Managing Director of Safe System Solutions New Zealand. He will be joining us in one of the later modules to have a chat about some New Zealand-specific processes and practices at a local government level and at a national level associated with safe system audits. And many of you probably know Sam. He's been around the road safety industry in New Zealand for quite a while, and he's leading our New Zealand team. So that is, the two of us will be leading the course, and our contact details are there if you have any specific questions about the content of the course. Anything associated with the admin management of it is the training team, Loretta and Marissa, through that training email, and anything about the technical content can come to us. A couple of other people who are going to jump in and give some specialist advice. We have Max McCardle, Engineering Operations Manager at Safe System Solutions, but he's a specialist in cycling safety infrastructure and pedestrian safety infrastructure, and will likely give us a few insights into that. And Fergus Tate, again, somebody you may know, has been around the road safety industry in New Zealand for a very long time, technical director at WSP, and Ferg will come in and have a chat, and it's always entertaining. He'll have a chat about detailed design, safe system audits. Now, Loretta, you mentioned this learning management system. What are you talking about? What is this thing?
I did. So I guess everything you sort of, assignment wise and quizzes, everything is on the learning management system. So we sent out an email. I can see that most of you have already logged in. I will point out, if you haven't received an email to log into the system with the password, check your junk mail. Sometimes it goes in there, or your spam folders. If not, contact us and we'll sort it out for you. But yeah, all the information is on the learning management system, but we will run through that later on, and I'll show you through.
Thank you. And it's nice to see some people saying hello in the chat. We've got Hamilton City Council. Hello, WSP Timaru. Oh, I love Timaru. My sister used to live in Timaru. And we've got SPA Consulting at Wellington, and Gareth has put in 120, which is confusing me. I'm not sure what that's referring to. Is that an answer to a trivia question I haven't asked yet? I like it. Okay, get access to the learning management system. If you don't have it, you're not passing the course. Okay, who's this little furry creature?
That'd be Wally, our little friend Wally. So Wally the wombat will appear on, well, I guess throughout the sessions. So on some of the slides, if you do see a little Wally, please keep count. So keep count of all the Wallies you see on all the slides, and there is a question in the quiz based on how many you have seen. And I believe that one's not included. So the one you see here on this screen is not included.
Not included, that Wally. But do keep an eye out for Wally. And there you go. Gareth's running multiple screens, so I had a mishap there. And understandable. But Wally's one of our little tricks to try and keep you concentrating on this. We know the online environment for training can be challenged. Very tempting to do that roundabout design or finish off that ministerial briefing that you had to do. So keep an eye out for Wally, because that's one of the questions in the quiz at the end. Another way we like to try to keep you engaged is by asking you lots of questions and you typing answers into the chat, having polls, having different things go on, and we'll give out some prizes. So how do we give them their prizes, Loretta?
Well, they can choose between Superman and Batman if they want. No, just kidding.
In the prize pit there, yes. I like that background. No.
No, we will post it out. So I'll keep track. Whoever's moderating will, keep track of who wins prizes in the background. Ken does like to give prizes. So yeah, we'll keep track, and then we'll send them out to you via the post, snail mail, basically.
Yes. And you'll get a copy of certificate as well in the post at the end when you successfully complete this course. But we say that successfully completing the course isn't just sitting there doing nothing. You actually have to pass a competency benchmark. So we have some requirements and then, a pass mark. So you have to attend 5 out of the 6 live webinars. So you're here for one, unless you're watching this as a recorded, I suppose. But 5 out of the 6, and view the one that you do not attend. You'll see a little disclaimer note there next to that. And it's just pointing you to go and talk to Loretta or Marissa, shoot them an email if for some reason you need to miss a second one. We need you to complete all the set tasks that we're going to give you. It's not onerous, it's not hugely onerous, but there are some things we are going to get you to do in this course. And then the pass mark is 80% for everything, okay? Now, that sounds high, but we haven't had trouble with past participants getting to that pass mark. And everything we're going to cover is, or everything we're going to test you on is covered in the content, and nothing is overly technical. This is more process driven. Do you understand the process? Can you have a logical look at things? But we offer one-on-one coaching if you are struggling. Okay, so if you're struggling with any of the assignments or the quizzes, you're going to have 3 attempts at it, 3 attempts. So you might do that first attempt, and if you get a low mark, you'll get feedback, and you might decide, well, actually, I want to have a chat to somebody. I want to get a bit more information. I want to get my head around this. You just simply shoot an email through, and we'll organize a one-on-one Teams or Zoom meeting with you and one of our senior safe system auditors, who'll be able to just go over the content again and chat with you one-on-one about it to make sure you've got up to that level of competency. So I think that covers off most of the general content. I want to acknowledge the traditional custodians of the lands that we're running this training on, and it's varied lands across New Zealand, and we're seeing that coming in from all across Aotearoa there, from the top all the way down to the bottom. So welcome everybody. I acknowledge traditional custodians of the land, and we're excited. We've got some locals coming in throughout the course that will be talking about different aspects of the New Zealand landscape and the road design and operation and road safety. So it should be fun. And get ready for some prizes as well, as I said. Okay, pop any questions you've got about the running of the course. If you haven't got access to the learning management system, shoot an email to Loretta now at the training email. But otherwise, I'm going to get into some content. And here we go. Safe system audits. Now, safe system audits are really a combination of a safe system assessment and a road safety audit, and they've been mashed together recently in New Zealand. But that's pretty exciting, and I'll explain why that's sort of exciting as we tick along. It should help to streamline a bit of red tape in projects, a bit of duplication that we don't need, and it also helps us in ensuring that the assessment methodologies are reinforcing safe system principles, which is what we really want to be doing. And it's really well articulated in Road to Zero, New Zealand's road safety strategy 2020 to 2030, which is there on the screen. No doubt you've got a copy of this by your bed and you read it most evenings. But if you haven't, then I'll point you at one little part of it, which is part of the KPIs, key performance indicators within this document. It's there, and the one that I'm particularly sort of pointing out associated with this course are these two. So a KPI is percentage of people who have completed approved safe system training course and showed improved understanding of the safe system. This is one of those, and you're going to be hopefully showing improved understanding of the safe system. Percentage of road infrastructure projects that have been subject to a road safety audit and or safe system assessment. And now we've combined those in New Zealand. So essentially subject to a safe system audit. So literally a KPI for the New Zealand government is how many projects are being subject to this assessment methodology that we're going to be learning. And you are then going to be applying, and you'll be out there doing it on these road infrastructure projects. So I'll explain that shortly. There's a Wally. There's my only help for you in this course associated with Wallies. Wally count is 1. Keep an eye out for future Wallies. Okay, so I mentioned the safe system. You saw it there as a key thing within the New Zealand government's road safety strategy. It's been adopted by local governments across New Zealand. Waka Kotahi operates under the safe system philosophy. But what is the safe system philosophy? Like most people I talk to in New Zealand will say, oh yeah, no, I know the safe system, and they've got a few sort of key points that they can control out. But I want to dig a little bit deeper into this and try and really understand a little bit about that philosophy, what it is. And to do that, I'm going to take you back in time. We're going to go back in time to the early and the first adoption of the safe system in New Zealand, like this time that the New Zealand government said, yeah, okay, we're going to adopt and we're going to operate under the safe system approach to road safety. And in fact, let's give out a prize. I'll give a prize for anybody who can tell me the year that the New Zealand government first officially adopted the safe system approach to road safety. Now, I should say you're not marked on anything that happens within the live course. So you can have a guess. You're not going to get marked. You only actually get marked in this course after the session when you're in the learning management system. So in the chat, freely pop it in there. We've got a guess already in. We're seeing a few guesses. You can just throw out some ideas. Vinay's closest so far, so I'm going to give the prize there. First guess and closest. Lewis has got the 2004 answer, which is correct on the official one. So let's give Lewis prize and Vinay, I think I'm pronouncing that right, hopefully. So 2003, it was very much being all discussed and different bits and pieces. In 2004, it was signed off. So it's been around a while. Eh? The safe system approach is the way that New Zealand's been operating in road safety for quite a while. And back in the day then, it was really interesting because this diagram was being floated around at an Austroads level. New Zealand was looking at it and lots of us. And I was in one of the state governments in Australia at the time, and I was sitting in the Austroads workshops with New Zealanders, sort of the Colin Brodys of the world, Fergus Tates, and we were having lots of debates about how this all plays out. And it was really interesting. This diagram was what was produced. And right at the middle of the diagram, you'll see there, it says human tolerance to physical force. Like, how much force can the human body take before it breaks, before it's seriously injured or killed? And what an interesting central starting point for the management of a road system. Like thinking about human biomechanics of injury, essentially. Right? And around that, you saw the levers of things that you could do to keep things within those limits. And they were the vehicles themselves and all the safety features within vehicles, the roads and roadsides and how those are designed and managed, and the speed of travel. And that was it. There was a circle then put around it. That was the whole system, right? That was all. And then some people in that workshop said, well, hang on a second. What about the people using the road? Like, surely they have to act safely. Surely that's a key element of this system. And that kind of split the room. And then you had part of the room saying, well, no, because like we have to create this system which accounts for human fallibility, like the fact that humans will make mistakes all the time. And they shouldn't be killed when they make these mistakes. They shouldn't be seriously injured. You know, there should be some sort of protection for being human. And then the other side is saying, no, like they are in control. They have a responsibility. They need to act appropriately and behave appropriately. And we can't possibly have a safe system without the human acting safely. And so this debate raged. And in the end, to sort of get it passed, well, we went sort of 2003 into 2004 with this debate. They put this square around it that said alert and compliant road users. Now, that to a degree was in hindsight, was a failure, really, because that just gave an absolute like get out clause for almost every death or serious injury we see on the New Zealand road network. Really, you can just say, well, they were not alert or compliant. They were not in control of the vehicle. They fell asleep. They dropped their coffee in their lap. They looked around at the kid who was throwing up in the back seat. They worked a double shift and drove. Like the list goes on. And I've spent the last 25 years, up to my years in fatal crash investigations and serious injury investigations and looking into cause of crashes. And like 98% of them, maybe 95% of them, I can just squarely blame a road user. It's so easy to do. Like there's always things. But you start to say to yourself, well, like, surely this has just got to be acknowledged that that's human. These mistakes are human. And that our system is got to be designed wrong if you make those sort of mistakes and it leads to death and debilitating injury for people. Like, so the safe system is all about countering that attitude of just being able to blame that individual for what is essentially an inherent systemic failure, but we just blame the individual at the top of the system. So anyway, that got thrown out after a few years. And all of these other ones emerged. And New Zealand was on the front foot of this, like, didn't really accept that from the start. And then we saw lots and lots of other diagrams of the safe system appear. I'm going to just talk briefly to the current New Zealand diagram of the safe system approach. And I want you to think about sort of the principles of it, the principles underpinning the safe system rather than the specific wording. We do have a little quiz in the session coming up, which is, you're not marked on, but it's sort of testing you. It's not going to be the exact same words, but it'll be the principles. But let's have a look at this. We see the principles around the outside here, and I'm going to just talk to these briefly because they are really solid world's best practice principles of the safe system, or sustainable safety, termed in different countries, or sort of vision zero planning and these sorts of things. But let's call it the safe system here. We strengthen all parts of the road transport system. We are thinking holistically here about the transport system. But this one is a big one. We design for human vulnerability. That is the biomechanics of injury of humans. And in this course, we're going to delve into that. So you understand different crash types, speeds, angles, road users involved, and what we would expect the outcome to be for those road users. So you're going to become a little bit of a biomechanics of injury person and analyst. We have a shared responsibility for improving road safety. That does not mean that we can push blame to the individual road users. In fact, it's actually the other way around. That's there to tell us as system designers, system operators, system managers, road designers, you can't blame a driver for falling asleep anymore. You can't blame a driver for being distracted anymore. We don't condone these things. We're going to try and do things to lessen them doing it. But it is our responsibility to design the road system that caters for somebody who falls asleep. We don't want them to. We're going to try and stop them doing that. But our responsibility is to think about what happens when they do. Our actions are grounded in evidence and evaluated. This in road safety is so, so important. And the reason for that is everybody drives, walks, rides the road network, and they've been doing it for a long time. And thus, they believe they're an expert in telling us what will improve safety. And this is a really hard thing as a road safety practitioner, is to extract yourself from your personal experiences, because you are not a statistically significant sample, nor is the person who says they've been driving for 40 years. And the number of letters I've read that start with, or the number of people in a workshop who put their hand up and they start their spiel with, I've been driving for 40 years on the New Zealand road, or I drive 50,000 kilometers a year on the New Zealand road network, and here's how you improve road safety. I'm like, this is not evidence of anything, okay? However, you do need to, acknowledge people's experience, how they're perceiving things, what they feel, and factor that into our decision making. But you don't make decisions on your action based on an individual's experience. You base it on quality research evidence that is statistically sound, statistically significant, and we can all say, yes, that has been evaluated and that is effective. Our road safety actions support health, well-being, and livable practices. Genius. I'm going to find out who actually put this into this. I'll ask Fabian Marsh for that. I'm going to give them a prize. The reason for this is road safety is polarizing in the community, in the sense that you talk to individuals in the community about road safety and why we see death and serious injury on the roads, and they will often point directly at extreme driver behavior, things that they see in the news, that ice addict who drove 180 down the wrong way of the motorway, or these sorts of extreme driver behavior things, the boy races down the main street and those sort of things. That's how they sort of perceive it, which is voids it from anything to do with them or their issues, unless they've directly been touched by road trauma in their family or friends or circles. And quite a few people have. So they sometimes have a different view on it. But when you take something like health, well-being, and livable places, this is making an area better to live in, just more friendly, a better place to be. House prices are up, the economy's thriving. It's all wonderful, right? They get in and support that, right? And in order for that to happen, you really have to have a safe, road system, transport system that sits in there. But we're sort of coattailing on something that is more tangible to people. So where I can, I coattail on other exciting things going on in terms of road safety initiatives, be that climate change initiatives, active transport initiatives, as it says here, livable places, health and well-being, any sort of occupational health and safety stuff, which comes up shortly. There's lots of things you can coattail on for your road safety initiatives. But telling some individual we're doing this for your safety, they're just going to glaze over in the eyes and come back with things like, oh no, you're doing it for revenue raising or whatever it is. Anyway, we make safety a critical decision-making priority. That's more in the background. We're not sort of publicly talking directly about that, but that's to say that decisions within transport projects, safety has to be a critical decision. We know that there are so many competing demands in infrastructure projects. There's so much going on. They're so complex. We need to ensure safety is up there. And through policy and process mechanisms, it's mandated that we do this process, the Safe System Audit process. We promote good choices, but plan for mistakes. That's it. We're going to do everything we can to make people make better choices, be more alert, be more compliant, and everything like that. But we are going to plan, design, and manage for when things stuff up, when things go bad. Okay, so that's a run through. It looks like we've got a raised hand. I'm wondering there, Loretta, if we want to give Gareth the opportunity to say something.
Yeah.
So hopefully, Gareth, you're able to.
Great. Yeah,
Hello.
just a quick one on. Yeah, good day. On the quick one on that coattailing, if you're involved in district planning, etc., and your community's got blueprint aspirations in their projects, it sometimes gives you a good feel for the temperament of your in your area. So if you're going to start looking at safety projects in those areas, you can just look at what those community aspirations were for and actually slip into the theme of it. We did that successfully at Waikato District Council a couple of years ago. Thank you.
Yeah. That's a fantastic example. Thank you, Gareth. That's the kind of thinking we really need to be doing, thinking where can we jump in and coattail along this whole process. I love it. I love that idea of it, doing it at planning stages. I always say that if we can get our planning right, and if we had got our planning right from the absolute get-go, we wouldn't really need a road safety industry, because everything would be pretty safe. So good to hear it's being done at that stage. Thank you, and thanks for speaking, putting the hand up. So there you go, people. You can either do it that way or you can type it into the chat. So within that, you can see those principles. They're sort of the safe system principles, and then these little circles in here are really the levers which we have to pull to achieve these principles. So we've got the vehicles still. We've got in here an added work-related road safety. And that's, again, a good little sort of coattailing on the fact that occupational health and safety at work is like super important, no compromises. But for some reason, if you're driving, they just throw all of that out the window. Like, that is a work task. Why are we accepting like a high level of risk in one part of the work task, but as soon as you get into the workplace, as in a physical place, you've got to be super safe. So there's a bit of opportunity there. Regs are choices, so it's still, there's still stuff in there to try to make sure we get better drivers and the like. System management, so the overall management of the system, and then we've got infrastructure and speed. And that's really predominantly what safe system audits are all about, looking at that infrastructure and speed and the way we can optimize it. But we don't ignore these other ones in our assessment. And you can see here the vision, a New Zealand where no one is killed or seriously injured in road crashes. But it doesn't say a New Zealand where there are no road crashes, does it? Because there is acceptance and acknowledgement that there still will be crashes. Our job is to manage energy. And here's a little thing to alter your perspective of your job. Okay, your job, you have an energy management component to your job. So you should be trying to manage kinetic energy in crashes. That's an interesting take on how we do things. But let's just explore this. I'm going to talk a little bit about safety culture, and then I'll give you some stuff to do. Okay, let's jump out of roads for a second. Let's jump to another industry. We're going to go into production of widgets in manufacturing, some sort of widgety something we're making. Back in the day, it was a pretty open system. They had lots of workers sort of coming in. They get kids off the street. They give them a bit of training, and then they tell them to clean the machines, and they get workers, and they again give them a bit of training and say, all right, well, you do a couple of days of training on how to use this, and then you're into it. We'll give you your ticket to work on this machine or whatever it is. But the whole area was quite unsafe. It had machines that would have open crushing mechanisms and cutting, and we would see people crushed and arms ripped off and the like, and people killed in these machines. And when they brought people in, they told them it was dangerous. They absolutely said it was dangerous, and they said, so you have to act safely. It's all about you. You got to take responsibility for your own safety. That's what we call a pathological safety culture, where it's up to everybody to protect themselves the best they can in an unsafe system. So then it goes to a point of reactive safety culture, where they identify, okay, that machine's ripping arms off, every couple of months. Perhaps we should alter the way that machine works, put a guard on, right? So you solve that problem as it comes up. Then there's another machine over there, and it has a problem that emerges, and you go and fix that one. Then the economists get on board and they actually then sort of review the whole, all of these factories, and they say, well, you know what? Like, if we were to implement these safety improvements across all of these machines or these different machines, we would actually make more money, because we would have less downtime, we would have less payouts to the families of injured and killed workers, and we'd be able to produce more widgets. And they find this nice balance where you just kill and seriously injure enough that you're still producing what you need, and the more widgets are being produced, and you work out a thing called a benefit cost ratio and find that nice balance. Then you step up from that in a safety culture ladder and you go up to what we call a proactive safety culture, where it says, well, no, we need this very high level of safety, and we will allow you to produce widgets up to that safety performance level. If you go more unsafe than that, your risk goes above what we've deemed the very safe level, production will stop until we're brought back into that envelope. And then you need to maintain that high level of safety through the maintenance of the equipment and the systems, but also maintenance of the culture and the like. Now, if you look at the sort of way we operate the road and street transport system in New Zealand, from a safety culture perspective, we really have elements of all of this. We've certainly got an abundance of pathological safety culture, where we're giving licenses to young people and saying, it's dangerous out there, you've got to act safely the whole time, safety is your responsibility, right? And we're sending them off into an unsafe system, with them being the ones that we say are responsible for safety. Okay, we have reactive, and we certainly have been treating a lot of areas that have crashes, and we continue to do that. Calculating is in there, and that's very much entrenched in decision-making culture in New Zealand around road transport, is that idea that we have to kill and seriously injure a certain amount of the community in order to move people and goods around the network. Well, you want to sort of counter that, and there is a lot of countering that coming about in saying, well, no, we need to, yes, move people and goods around, but we can do that safely. There are proactive elements in there. We're seeing more and more emerging, and that is really where Safe System sits in this proactive and then maintaining culture, where we see things like new motorway roads have continuous barrier systems throughout the roadside and median for the full length of it, right? It's not calculated on a BCR perspective. It's not waiting to see where people run off the road or have head-on crashes and putting short lengths of barrier in there. No, it's saying from the start, we need it to be inherently safe from that perspective, and that's what happens, right? If you ran a traditional BCR method over that, economic analysis method over it, probably wouldn't come out well. But I always give the analogy of like a new high-rise building, apartment building with balconies, and you don't build that and then just wait and see where people fall off and then put a bit of railing on those balconies. Or go, oh, well, actually, it's higher risk on the outside of the curve of the balcony, so we'll just put the railing on the outside of curves. No. All right, it just says it's unsafe. Without railings, we put railings. And that's the sort of, proactive safety culture we're looking for. So there's good stuff there. I mean, back in the day, school speed zones were very much in the proactive. You run a standard economic analysis on school speed zones. They're disastrous investment in an economist's eyes. They're just bad all round. There's just nowhere near enough kids killed or seriously injured in their minds. But how grotesque is that? Like, we don't accept that. We say, absolutely not. These are kids. We're not going to accept that, right? We'll all just go a little bit slower around schools. Yeah, so we need to take that sort of attitude and just afford it to the whole traveling public. I can explain in a lot of detail why school speed zones in an economic model are bad. Now, some people like the real, professor of economics will then have like many hour debates with you to talk about why the model you're using is wrong. I mean, I'm like, but that's what transport agencies use as their model. So it's not taking into account the externalities and all these. Yeah, anyway, I've got to keep moving on because I'm already well behind. How about we do a little pop-up quiz? 2 questions, one of which we've sort of gone through the philosophy of, and the second we haven't at all, and you're going to have a guess at it. I will give you a stretch break in a bit, so answer these quickly, and you're not being marked on this, remember. This is just to keep you interactive. It should have popped up on your screen. Don't worry if it hasn't. Again, you're not being marked on it, but pop your answers in, and then we'll keep ticking along. We're doing pretty well here. I'll give you another 10 seconds. Okay, let's end that poll, Loretta. Let's share the results, see how everybody went. Which of the following is not a key principle of the safe system? So remember I said the wording will be slightly different to what we talked about, but the principles, philosophy will be the same. And the bulk of you are spot on. So we're not aiming for no mistakes on the road because we're absolutely like grounded in reality to say that people are still going to stuff up. We're going to try and make them better. We're going to minimize mistakes, but we're going to manage them. So aiming for no mistakes on the road is not what we're doing. Trying to minimize mistakes, absolutely. Usain Bolt, interesting question. I think some of you were doing back of envelope calculations, 100 meters, 10 seconds, meters a second, conversion to kilometers an hour. Maybe you didn't account for the fact that acceleration was required, and this was the speed crossing the finish line. And the answer actually is 44 kilometers per hour. So well done to the 7 of you who guessed that one. 44 kilometers an hour. So why am I asking that within a road design assessment type course? Well, I want you to imagine us parking a Toyota Camry at the end of Usain Bolt's lane as he runs down that 100-meter sprint track, and then he gets to the speed of 44 kilometers an hour, and then bang, he runs into a Toyota Camry. Is he going to survive? Well, the answer is yes. He'd probably survive, and he probably will actually only hurt himself to a degree that he'll recover. He'll mess himself up a bit in the short term, but he should recover to lead a normal, healthy life. In fact, humans are kind of designed to run into stuff, or evolved to run into stuff off the pace of our own legs. So running full pelt into something like this is survivable. That's going to hurt him. Yeah, he's hurt himself a bit, broke a couple of ribs, but recovered, came back the next year and won the gold medal in the Olympics. Like, there's a little experiment you can do to prove this, which is to run at your full fastest pace at a tree, and you should survive and lead a normal, healthy life. You might need, you break some bones probably and knock yourself out maybe, but in theory, you should survive. So you can try that if you want. There's a correlation there as well. Like old people can't run as fast, nor can they handle the forces of higher speeds. So neat little correlation. Of course, there are bits that occasional things that pop out either side of it, but that's how we evolved as humans. Now, this then becomes a design parameter in roads under a safe system. Like, okay, we know that there's a certain amount of force the human body can handle. That should be a design parameter. The same way our flood level, we're designing to a 1 in 100-year flood, right? We're designing to V3 lighting levels, and we're designing to the human body's biomechanics of injury. That's how we should be thinking about it. But you're going to need more info than just that, aren't you, in order to make those design decisions and those operation decisions within a road network. And we've got some more data and evidence for you. We don't have it all, but there's lots and lots of universities around the world working on more and more of this. But we have down here collision speed, right? This is speed of impact, not speed limit. Don't get that. Okay, speed limits, we'll talk about them later. Speed of impact. This is like physics. This is biomechanics of injury. Collision speed, and then chance it's going to result in death to a member of our community. And so this is a graph for all community levels. And passenger vehicle, striking pedestrian. And you can see there around 10, 20, 30 kilometers an hour. Most of our community will survive when struck at those speeds. It's not going to be friendly, but they should survive. A great man, he came up a little higher up the curve because he's built like a fridge and can withstand some force. But you see there, it sort of exponentially goes bad for our community around that 30 kilometers per hour. So like it gets really bad really quickly after that point. For side impact, right angle, we talk about that vehicle as the bullet vehicle. The bullet vehicle is the one that does the damage in a crash. This is target vehicle. So bullet vehicle speed down here, we see that around the 30, 40 kilometer per hour, when we get that right angle crash, the T-bone crash, bullet vehicle speed, they're generally survivable, even up to around the 50. As we go beyond about 50, it gets really bad, really quickly there. And we see, huge increases in the proportion of our community killed as a result of those at higher speed. And for head-on crashes, we see there that around the 50, 60, 70 kilometer per hour, which is the speed of each vehicle, right? So sometimes people say to me, oh, okay, so it's 70 kilometers per hour. That's 140 kilometers worth of force. And I'm like, no. Well, I'm like, yeah, only if you were standing in the middle of it and they squashed you. Or only if you're in a little tiny smart car or something and a massive truck hits you and pushes you back at 70 kilometers an hour is 140 kilometers per hour worth of force. It's a 70 kilometer per hour crash. It's the same as running into a brick wall at 70 kilometers an hour in the sense that assuming these are same mass, same speed vehicles and they hit head on, the occupant of those vehicles goes from 70 kilometers an hour to 0 in that short space of time. Good Mythbusters episode on that, crashing cars into each other and into brick walls with accelerometers and proving that point. Now, in the PDF slides, which you can get from the Learning Management System, as Loretta's going to show you near the end, you could click on any of these little safe system snippets, takes you to a link, gives you some more information. Sometimes there's videos to go with it. If you're interested in delving into this a little bit more, we point you at that. Okay, so we've got this interesting information here, but and that gives us a nice grounding in sort of how bad are things going to be when they happen out there. But we've got more and more stuff out there. We've got heavy vehicles, we've got motorcyclists, cyclists, we've got cars, we've got trees, you know, all these crash types that can happen. So we've created this little chart to give a bit more information about the severity of injury, different crash speeds with different crash types. All right. And you can see it's not a very defined, you know, at 49 kilometers per hour, everybody will be safe. At 51, everybody will be killed. No, it's a spectrum, and there's so many variables in it. All right. But this is a general bit of guidance that we know, sort of a side impact, crash, heavy vehicle versus car. You know, we can talk, you know, if it's happening at 80 kilometers an hour, then we're in big, big trouble. You know, 50 is still going to be serious injury, sort of, and potentially death. But if we're doing that at 20 kilometers an hour, we're sort of in the more survivable ranges. So that's generally how you can do it. You can see a little window into some future stuff we're going to do in scoring this. So spoiler alert, we are going to put scores to this later down the track. So you're going to predict a crash, and then you're going to score it on how bad the outcome is going to be in terms of death and serious injury to our community, but we'll get to that. I'm going to give you a break shortly. I just want to cover off another couple of things here. This one. So this diagram pops up a lot in road safety, and it's the like bane of my existence. It just infuriates me when people bring it up, and it's not because it's wrong, right? It's because of what people do then after they see it. And it's just so often I find people sort of newish to road safety, they jump into the literature and they're reading about road safety, and they discover this, and they're like, okay, this has given me something I can really work with. And then they go off on really bad tracks. But let me explain what it is. It's a crash causation diagram. And it comes from, well, this one happens to be the Kimbler study of 2003, but there's like one of these, the world's biggest and best crash causation study about every 10 years. Somebody produces one, they, you know, do in-depth root cause analysis of, you know, 1,000, 2,000, 5,000 crashes, and they have the most massive database you could ever see. And it's amazing research. These people are brilliant, right? And they always come out and they say that the road user is 90 to 98% of the cause of crashes. Road user error, failure. And this Kimbler one was just drivers, but we've seen them with motorcycle riders, including pedestrians and others. The road and the road environment interacts and plays a role in that in a small percentage, and the vehicle in an even smaller percentage in its own right. There are very small occurrences of time where vehicle malfunction is the root cause, and road malfunction is the root cause, but those are sort of lower. But why is that so bad? Because as a result of that, people go, well, we need to invest our time, money, and effort into fixing the biggest cause of crashes. So we need to change the humans. But the humans are like far and away the hardest thing to change. I mean, I suppose genetic engineering is coming along leaps and bounds, and we can actually start to do things, but that's going to come with some other pretty catastrophic societal change. Well, maybe not catastrophic. That's a whole different debate to have, and I'm not an expert in. But really, you would need to fundamentally change humans, like from some sort of DNA level, in order to start to seriously lessen this. Like, yes, we can continue to get small improvements, but the other thing is it is just unsustainable. Like, every time you invest a huge amount in improving the safety of an individual, then there's another one that comes along. You've got to do it all again, and another one, right? They just keep appearing, right? But if you address the systemic risk of an intersection, it's addressed. So, yeah, this is where we've altered our thinking on that sort of diagram and say, okay, all right, take away the root cause and call it a system failure, right? Yeah, of course the human failed. That's part of being human, right? Why did our system not kick in to prevent it from being death or serious injury or prevent it all from happening in the first place? And when I say our system, why didn't the vehicle intervene? Why didn't the road infrastructure intervene? Why wasn't there some intervention that happened before this person even got into a vehicle? Like, these are all things that we should be thinking about from a system level, right? Now, there are bubbles here that Austroads put, it's adapted from Austroads, which were these driver access, driver inexperience, and bits sitting outside, little bits sitting outside. Now, there's another area of debate, like, okay, if somebody drives at 200 kilometers an hour through a residential street, is that even something within our system that we are? I would just say it's a system failure. Like, how on earth have we let a car be able to do those speeds in those areas? Like, that's insane. And the technology is there to stop that happening. Like, that's, technology is not the issue. It's sort of like a mix of sales and marketing and public opinion and all of these weird little nuances. But from a very simplistic perspective, that we could make it so that absolutely just can never happen. It can't happen. The vehicles will not let that happen. Driver inexperience is like not having absolute basic function of how to use a vehicle that you're using. No, and we're not talking about anything advanced here, just absolute basic function. But we want to think about system failures, and what can we do to address the system? Within that, we talk about slips, lapses, mistakes, unintentional violations, and deliberate violations. And that's like Loretta, actually, sorry, we do have that little second poll, I just realized.
Okay.
If it's still in the system.
Yep.
I'm about to give everybody a break, and I'm going to get them to do the poll as they take their break, because I like to make people work during their breaks.
Yep, that's fine.
Okay, but human error is, it's bloody fascinating. You should, there's this interesting report from the University of Adelaide, the Centre for Automotive Safety Research, that delves into like understanding human failures, human errors in road transport and basically in car crashes. And it categorizes and it talks about a lot about it, right? But the end output categorizes things into these failure mechanisms, and about 30% of crashes in New Zealand sit below that line. They've got about 70% sitting above that. And those are deaths and serious injuries. So the media will have you think that 100% are deliberate violations, like, that real, like, I'm going to go out and, as I say, I'm going to go out and ride my motorbike at 200 kilometers an hour through the Rimatunga Hills or whatever. Like, those are deliberate sets of, I know the rules and I'm going to violate them, right? But the bulk of death and serious injury on New Zealand road are people generally going about their daily business and unintentionally failing, falling asleep, being distracted, or these sorts of things. Now, it does get very interesting and nuanced where you draw that line. I'm not going to get into that. But I just want to take away that idea that all of this is people doing these deliberate violations. Now, I will admit, below this line, I don't really know what to do. I know it's a bigger societal problem. I know people have a lot of issues that they're in their lives, and they're transposing those onto their driving and riding behaviors, and we've got some real challenges there. that needs a real shift in thinking. Above this line, we know what to do, and we can address with infrastructure, speed management, and the continuing of evolving of vehicle safety features. We can address almost all of these. Okay, so I think there might be a question that's come in.
Yeah, there is a question. Is deliberate include drink driving, etc.?
Yeah. So this is where it gets a bit nuanced. I think they drew a line at some sort of intoxication level, which was, not just a bit over, which, is up for debate. So a bit over seemed to be within what they categorize slightly as above the line. And texting was also above the line. So whether that's a premeditated, deliberate violation is unknown. I mean, I think that in the report, it was sort of like, the predominance of texting and the way people, when the text goes, the human urge to look at it is not considered a deliberate violating act. So it gets into some, interesting details, lots of psychologists and human factors experts and the like weighing in on those reports and those sorts of things. But yeah, it is interesting. But I mean, the core of it is that there's a huge amount we can do just within the design, operation, and management of the physical infrastructure and the way we operate a road and street network that can have massive, massive changes for everyday New Zealanders going about their business. They'll never know, but it can. So here's our little exercise while you have a stretch break. So you're going to get 5 minutes. And what I want you to do is there's going to be a poll that pops up on the screen. I've generally been talking about the difference between traditional approaches to road safety and the safe system approach. And all you're going to do is try to match from traditional, we had victim blaming. Well, under the safe system, there's, pick one of the other ones. Again, don't get overly concerned about it. You're not being marked on it. It's just a way to consolidate our thinking. And some of them could go to multiple different ones. So 5 minutes, have a crack at that. And have a stretch, fill up your coffee. We'll get back into it now in 4 minutes and 45 seconds. See you then. Okay, we will get back into it shortly. And as I mentioned, don't worry if you didn't quite get, a few of these could go to multiple places, really just a way to consolidate thinking. So it's all good. 10 more seconds. And okay, let's end that poll and share the results. Although I might just actually, I'm going to stop sharing that. And I'm going to show it on screen. I had a quick look at what was coming in there. But victim blaming, well, we now people won't say they were victim blaming, of course, but where we just are able to point the finger and say there was a minor lapse in concentration and that caused it, or whatever it was. It's more recognizing human error, minimizing its consequence, and that shared responsibility. Emphasis on road user education and compliance. It's not being ignored, road user education and compliance, but it's more focused now on that effort to create a forgiving system. So crash reduction, we're thinking about the consequence of crashes and severe injury minimization. We had this very siloed 4-pillar approach: the roads, the speeds, the vehicles, the people. It's really understanding there's this multifaceted system, interacting elements, and we want to optimize it jointly as an interaction. That's a bit of a mouthful, that whole sentence. And mobility safety balance to maximizing safe mobility. That's a little bit like that sort of factory widget analogy which I was giving there, where we say, well, no, the safety sets here, and then we will maximize mobility within that safe envelope rather than balancing off. Okay, let's have a quick little pop in here of some things. I'll give you a little bit of background on this. And sorry, I'm just checking where we're at. Right. Okay, I'm gonna have to speed up a little bit, but that's okay. So this is a central a barrier system, flexible barrier system in a narrow flushed median, as you can see, pretty newly installed system, 2+1, meaning 2 lanes in this direction, 1 lane in this direction, and then that'll swap at some point. So you've got that overtaking opportunity. There's a little bit more of it. You can see, okay, this job took an extraordinary amount of time in planning, design, development, because they kept hitting these hurdles and these barriers and things that people said, you can't do it, you can't do it, you can't do it, for one reason or another. And let's just do a little bit of typing into the chat. What do you think some of those blockers, some of those hurdles, some of those reasons people put forward why this project to add this central median barrier and the flush narrow median, why they said you can't do it on this road? It was just a road that was basically 1 lane in each direction with occasional overtaking lane separated by a center line. And this was the change that they were making. Pop it into the chat. Any ideas on why you think, what are those challenges? People were saying, you can't do it, I don't want this. Okay, I'm seeing a few come in. I'm going to give it a second. Okay, constraints, yeah, from Gareth. Let's be a little more specific with that's okay. We're seeing a few others come in now. Access to properties, that was a good one. That definitely came up in the sense that people wanted to get access to their property, and now there was a barrier down the middle of the road, so they could only access it in one way. Okay, excavation, a loss in environmental. Yes, that came up to get a small bit of widening. Too narrow in terms of too narrow, the median's too narrow. That was definitely one that came up, and the deflection of the barrier system. Low crash history. Yeah, so that economic analysis argument, oh no, there's not enough people killed or seriously injured here for us to do that. No free overtaking opportunities, absolutely. Total cost of the project, land purchase, and all of that. Yeah, it's a good one. Maintenance. Yeah, maintenance came up as a big one. I'll give a prize out for maintenance. Not that the others weren't absolutely relevant and good, but maintenance was an interesting one, and one I probably didn't expect to come up as much of an issue. But it was not just maintenance of the barrier system when it was to be struck, but it was like maintenance of a pothole or patching in these areas and how they would manage traffic around it. So lots and lots of issues. Enforcement, if this car was driving fast and the police car was on this side, well, how would they get to them? What if the house over here was on fire? Would the fire truck have to go all the way around? The posts and motorcyclists, the list goes on and on and on and on and on. And you've identified a few of them. There were many of them. And the thing is that this is still not something that is done commonplace. And so people are not used to seeing this, and change is always fearful for people. And so we see a lot of this come up. So our job is really to think about, okay, how can we facilitate this? Because this is going to be a way, way, way safer outcome for our community. And one of the ways that we've discovered with this is that a traditional road safety audit, right, it actually caused more issues for these projects in a lot of cases, because a road safety audit in its own right, its only mandate is to identify safety issues with the project once it's built, like with the design. So all all the road safety audit was pointing out was the risks. You know, maybe the motorcyclist hitting this, the deflection of this barrier slightly into the oncoming lane, little bits and pieces like this. The audit's job was never to say, overall, this is a wonderful safety project. That's not the job. So we ended up getting these reports that were kind of hampering our ability to implement these sort of things. But the safe system assessment process, it does that. It actually sort of quantifies this overall safety benefit of a project. And so that's the wonderful thing about a safe system audit that we're talking about now in New Zealand, which is that it front loads this report with the safe system assessment, the scoring, and it'll show you this is a great project. Now, here's some little specifics that we need to think about and see if we can address and minimize the risk of. Overall, massive saving in deaths and serious injuries to our community, some little things to work on. And so that's really quite an exciting part. That one did get built, of course. Then it got hit. Of course, it got hit because, you know, people leave their lane. And that was a really interesting one. And somebody called up the regional office. They wanted to speak to the engineers that put this in, and they were expecting to get shouted at, as you usually do, except for this person just wanted to thank them because they're pretty sure this barrier saved their life. And they've been driving this road for 40 years, they said. And yeah, it's never had a barrier in the middle. And this time it did. And somebody came directly at me. And so they managed to capture that person and give them to the comms team. And they made a little video of it, which we're going to put into the learning management system. You want to watch a little 2-minute video that talks about that. It's pretty good. It's pretty nice video. It's very rare we get thanked for, you know, the work we do, because people don't know that they've been saved. But in these cases, they do. So a couple of little things from me here as we go through these principles and these elements of the safe system. The vehicles are playing, you know, a huge role in safety, right? And we're seeing better safety features coming into vehicles. We're seeing different star rating systems. We're seeing mandating of different safety features. Admittedly, the New Zealand regulations are lagging significantly behind a lot of the rest of the developed world, and I think there's a lot of improvements that can happen in that space. But we do know the vehicles are playing a pretty good role, and you can see some crash testing and some vehicle safety features implemented into the vehicles, which are proving pretty good. But I do want you to be aware of the limitations here. For us as infrastructure people to sit on our hands and say, no, the vehicles are going to solve all these issues, we don't need to really change anything. Yeah, that's not quite right. So that's not quite right on a number of levels. One is just to understand the limitations of vehicles. So this is side impact poll test under the Australasian New Car Assessment Program, right? So the way this test works is that you slide a vehicle at a certain speed at a pole, and then the crash test dummy can't have forces exerted on it that exceed essentially a level 3 serious injury, which is basically acquired brain injury for the rest of human's life. It's pretty much, it's really bad. So vehicles slid in at a certain speed. I'll give a prize for the person who can guess the speed that car is slid in at the pole. I just have a guess. Pop in some guesses. Okay, so we're seeing some range there. Everything from, I think we're seeing everything from 30 to 130. Oh, no, 140 we even saw. Okay, so I'll let Loretta work out who was, I'm just checking. So 32 kilometers per hour is the speed that it happens. So whoever said 30 gets a prize. That's closest. 32 kilometers per hour. That's the side impact pole test speed. Okay. So if you have a 5-star vehicle, it's really not designed for crashing into a side impact into a pole above 32 kilometers an hour. Some of them will be a little bit higher, but you know, the speeds that we travel past trees, power poles, and other point source hazards is well above that. It just shows you the limitations from that perspective. The offset frontal crash, 64 kilometers an hour. Pedestrian crash is actually 40 kilometers an hour, which is quite interesting. So you crash into a pedestrian, and most vehicles these days, or certainly any vehicle off the production line, you know, 2023 will have, you know, the bonnet will pop up when you crash into a pedestrian. A lot of them have airbags that pop out. You know, there's a nice bit of thinking about pedestrian protection, which is pretty good. But you know, we're limited in what can be done. So that's one reason. The other is that, you know, a vehicle that drives itself is going to be pretty exciting and good in the sense of, I showed you those early diagrams that we said like 90+% of crashes are human failure, human error, human mistakes, right? Well, if we take the human out of it, then we're doing pretty well. But this is not going to be happening anytime soon. Like there's lots of excitement, you know, you see the Waymo vehicles in San Francisco driving around by themselves, and you know, that little shuttle that potters around the beachfront without a driver and these sort of things. So we all get super excited. But there's these levels of autonomy, and we're a long way from seeing vehicles like this being widespread used in the New Zealand environment, and that are not like very tightly geofenced. So there's 5 levels of autonomy. Level 4 autonomous vehicles, they don't need steering wheels, but they can't go in like they're geofenced. They can only go in certain spots. A level 5 is that full vehicle that does everything that a current vehicle and driver would do, but it just doesn't need the driver. Like the advantages we're going to get is where we're seeing more and more move up into level 3 autonomy, which is essentially that the car there's a steering wheel and a driver, and the car lets you pretend you're driving, right? It's really going to take over when it needs to. It makes decisions on that. A lot of vehicles have elements of level 3 integrating into them. But the long and short of it is there's huge amount of analysis being done by transport agencies around the world as to, you know, do we do infrastructure improvements? Or would it be better just put all our money into vehicle technology? And they always come out with saying, well, no, the infrastructure improvements and the operation of our network still is the best investment. We continue to change and push auto manufacturers and others to you know, encourage safety outputs and the like, but we recognize the limitations. And then there's the whole way it rolls out and plays out, and the legislation and the interaction with vulnerable road users, and then, you know, you can get into like then system hacking and failures in all of that. It's fascinating, but the long and short of it is that we'll just see it continue to integrate in, but we still need to work on it. We're seeing here, you know, vehicles braking by themselves, and the one advantage we will have is that, you know, it's funny to see the little crash test dummy's leg fall off, but that's a success in the sense that vehicle braked and then hit at low speed, and we'll see some lessening of severity of incidents that occur out there as well. But let's talk about their speed. So some just very basic reminders of speed and the importance of speed. So let's take here travel speed on the y-axis, and we've got a distance where some hazard appears. So maybe somebody steps out from behind another vehicle like we just saw in that video. So at 45 meters, right, 60 kilometers per hour, the vehicle's traveling along. In a normal vehicle, the bulk of, the New Zealand fleet, there's reaction time. Then there's braking distance and the physics of braking. And at 60 kilometers an hour, they would just touch something at 45 meters. If we go up 10 kilometers per hour, up to 70 kilometers per hour, right? Reaction, braking, hits at 46 kilometers an hour. But it only went up, we were only 10 kilometers an hour more. Okay, it is not linear. That's the key. It's not a linear relationship, right? Increased speed, much more increase in impact speed. And when you add into that, those exponential charts we showed of the biomechanics of injury at different crash speeds, and you overlay both of these, we discover a fourth power relationship between speed and fatal injury outcomes, and a third power relationship between speed change and serious injury. So if that doesn't quite make sense to you because you were asleep in year 11 maths, that just basically means that small increases in speed magnify significantly to the highest level injury outcomes. So we can get some really great improvements with small reductions in speed, and we get really poor outcomes with small increases in speed. And I created this little, I don't know if you call it a meme or not, but anyway, I think I'll post it on LinkedIn at some point when I get around to it. But I'm saying that small changes in vehicle travel speed magnify up to relatively large changes in stopping distance, which creates this larger change in impact speed. And then you use kinetic energy equations, which basically square stuff, and we see in their larger impact energy changes, and a very large change in then the probability of death or serious injury. So there's my little magnification meme. And I was updating the Austrade's Guide to Road Safety Part 3, which is speed and speed management. And I chucked in this diagram just to illustrate the importance of speed in the overall sort of safe system perspective. But basically, you can have whatever road transport network you've got, like whatever the roads are, whatever the vehicles, whatever the people, you can have a safe transport system as long as you filter it through the correct speed. Right? You can have really bad cars. You can have drivers who not wearing their seatbelts and all these other things. You can have poor roadside infrastructure and the like. Filter it through a low speed and it's safe. Conversely, if you have a really excellent vehicle fleet and high safety features in all, and you have wonderfully designed roads that cater for this and have really great energy absorbing characteristics and don't have dangerous locations, and the road users are wearing their seat belts and the like, you can filter it through a very high speed and still have a safe transport network. In fact, racetracks are a very well aligned safe system environment, like car racetracks. Anyway, just the importance of speed. Safe speeds, though, we can achieve that through infrastructure and/or speed limits. And explaining why speed limits are in place can assist in their acceptance and compliance. That's a little bit of an interesting one. Protection of vulnerable road users is generally well accepted. I think urban speed limits are generally an easier thing to do. I mean, it's still hard, but our rural environment speed limits still cause challenges, as they are playing out very much in New Zealand at the moment, with some political challenges, as you're all very aware of, no doubt. But we are playing out this interesting space where we're managing speed, and we have some technology that we can do it. So we're site-activated speed limits on major roads. So these are, RIORs. They're sometimes called rural intersection activated warning signs or speed signs, where a speed limit activates only when there's a vehicle coming out of a side road or entering into a side road. So only where the risk, the conflict is present at that time. And I think these sort of things are a stepping stone into more appropriate speed management across the network. Okay, a few more things, and I'm going to make sure I give Loretta time to show you through the learning management system and show you a little quiz we've got for you. But here's the little diagram of where we've come from to get to the Safe System Audit Guidelines, which Waka Kotahi released earlier this year, actually. So the Austroads Guide to Road Safety Part 6, the 2022 version of it, is the Road Safety Audit Guide. I was technical advisor to Austroads on that document, and there's a lot of challenges when you have a very entrenched process like road safety auditing, and people's willingness to change things and acceptance. And if you've ever worked on an Austroads project, it's like like herding cats is an understatement. So it's very hard to get this major jump. Like we did some pretty good updates, but it just wouldn't. Some of the things we were trying to get done weren't being accepted by some jurisdictions in the Austroads community. Others wanted more, like Waka Kotahi or New Zealand as a whole wanted more. So then we also had the Safe System Assessment Framework, and then there's the old 2013 Road Safety Audit Procedures for Projects, which is the old New Zealand audit guidelines. So taken bits of each of these, right, and a few other little bits and pieces, and created the Safe System Audit Guidelines, which actually does, in my opinion, jump ahead of the Austroads document, and it's a really nice, process. So a safe system audit, though, is this overarching encompassing of a road safety audit and a safe system assessment. And so what we're going to be teaching you is really how to do a safe system assessment, and then how to do a road safety audit. Okay, and then how to combine those into the one package. But really, you will be able to do both a safe system assessment and a road safety audit, and you'll be able to do that combination as a safe system audit. And I apologize for, the fact that it might be a bit confusing with terminology as during this transition, but I will refer to safe system audit, which is what we're doing, but it really is within that a safe system assessment and a road safety audit. Okay, so a common misunderstanding of a safe system audit is that it's a check against standards. That's not what it is at all. Okay, I shouldn't say at all. You might check, okay, is this meeting standards and guidelines, right? But there's plenty of things that meet standards and guidelines that present death and serious injury to our community, right? We could have standards and guidelines that are old. We could have standards and guidelines that have never been thought about in this context that you're about to put them in. We could have combining standards and guidelines together, right? As isolated things, they're fine. They're quite safe. Put them together in the same spot. Oh my God, we've got a dangerous situation. So there's a whole lot of reasons why just meeting what is documented may not be safe. So our job as safe system auditors is to look at this from a pure safety perspective, not be driven by does it meet or not meet standards or guidelines. that might help you a little bit, because standards often are quite good and have thought about a lot of safety features. So you might want to have a look into that, but that's not the driving force of a safe system audit. And here's an example. Like, here's a vehicle that breached a barrier system on a newly constructed road, designed beautifully to standards and guidelines, following the absolute letter. And hypothetically, well, not hypothetically. Okay, if this is a test level 4 barrier system, test level 4, does anybody know? Pop it into the chat, have a guess. What weight of vehicle was that tested at? What weight of vehicle do you think that barrier was tested at? So in a test lab, they crashed a vehicle into it at 100 kilometers per hour, 25-degree angle, to say, yep, okay, that barrier configuration will withstand that. So Jerry has just hit the nail right on the head with 10 tons, and it's correct. It's 10 tons. So prize there. It's a 10-ton vehicle. That's the vehicle, right? So we know that barrier would likely, and I can't absolutely say it will, but it has been tested to hold that vehicle. This vehicle is going to be way bigger. And in fact, this vehicle does have another, it's a B double. So it's got another one of this. That barrier was never designed to withstand and contain a vehicle of this size. And it's breached that barrier. The driver's been killed. There was possibility that the gantry could have gone over the carriageway. And so what we are trying to do as safe system auditors is predict this sort of incident before it ever happens. When that was a design, even though it met standards, we could have been saying, well, hang on a second, this is a brand new motorway and you're going to have a lot of heavy vehicles. And are we going to have some of those leave the road? And what will happen at different locations when the vehicle does leave the road? So that's our role as safe system auditors, trying to inject this thinking and not be constrained by yet it met standards. Here's another example. Okay, so here we've got a new duplication happening and a really big new major subdivision happening all down here. It's huge, right? Not across the road, but yeah. And I'll zoom in on this a bit. You can see there's an intersection up there, existing, and big new access road in here to the new subdivision, which doesn't exist at the moment. So let's zoom in on that. Okay, so you can see here Main Street, and they're signalizing here. And you can see if a vehicle is traveling along here, maybe at 60, it's a 60 zone, maybe they're going 65 or something, they're ticking along and they're continuing along straight, and they want to continue straight along here, going straight, and oh, whoa, I'm in a right turn lane. Okay, that's what we refer to as a trap lane. Wonderful naming of that, whoever named that, because it's exactly what you feel. You're driving along and all of a sudden you're in the turn lane. You don't want to be in the turn lane. You didn't move into a turn lane, you're trapped. Okay, and we know, like, absolutely, like, very well that we're going to have side swipe and rear end crashes around here. Like, we know it very well. Does this contravene standards and guidelines? Well, not really. Like, it's discouraged, but it's not like, it doesn't say you must never build a trap lane, right? It's because these jobs are super hard. Like, they are dealing with services, properties, constraints, traffic modeling, cost implications, and you name it. Like, super hard to build something like this and design it, right? And so the designer here would have known they're building a trap lane or designing a trap lane, but they're going, well, I can't. I'm stuck here. I have to do it because I can't afford to widen. I've got this and all these other constraints, and on balance, I'm just going to do it, right? Our job as auditors is kind of exciting in the sense that we're freed of all of those other challenges, and we simply tell them what we believe will cause crashes to the traveling public. Now, we may try to help them in the sense that when we make recommendations, we help them out with some of the, understanding their challenges and try and work with them on finding solutions that may be possible within the confines of the scope of their project. But we see it and we report it. It doesn't matter if it's hard for them to fix and challenging and everything like that. It's an issue and we report it. Now, a little exercise for you, and we'll do it very quickly because I'm running out of time. I'm going to play this dash cam footage a few times. It's a crash that is about to happen. And I want you to type into the chat, what are some of the characteristics of the road environment, physical infrastructure, that you believe could have contributed to the chance of this crash happening? I'll play it a couple of times and then you just type in, what are some of the characteristics of the road environment? Don't worry about the driver's particular behavior, but what are the characteristics of the road environment that may have contributed to this crash happening? Okay, I'll play it once more, or a couple more times. I'm seeing some good answers coming in already. We've got a group of natural safe system auditors, I think. Okay, I'm seeing some really good answers coming in here. Okay. Oh, wow. So everything I'm seeing in there is worthy of investigation, and you can hardly ever do this. I mean, you can't do this from a video. So this is just sort of a training exercise. If you're out there, you'd pick up lots of things, but a really interesting one. So there's a bit of, people thinking it's a roundabout and people not thinking it's a roundabout, being confused. Yeah, that's a fair thing to be confused by. And I'm sure some road users might be a bit confused. It's actually not a roundabout, but it's very hard to tell that from what you've seen. But I'm really liking the way people are thinking about this. We're thinking about, well, the approach, is it clear there's an intersection? Are we given good advice there? Do they know it's coming up? Do they know got to stop? Is it wide? Are they going in high speed? And there was one I just saw, and it's got a username there. And I'll let Loretta, you've got to work this out. So the one is bland, no appreciation of an intersection coming up. I think that's, there's some interesting stuff associated with that. So prize for that. Sorry, and there's lots of things. People are looking at sight lines to the side. Here we've got signs blocking other signs. We've got this wide approach. We've got straight. We've got coming around a curve. These are all really wonderful things, and I don't want to downplay any of them because I think you'd want to look at all of these in detail. But this see-through effect that's there, and it's kind of links in with that bland. And are we even sure there's an intersection there? The geometry of a road and the like is hugely influential on crash chance. And I think I did also see somebody talk about self-explaining roads in there. So that's a prize-worthy comment as well, because they're interlinked. But there's this term that we use in auditing often. It's called visual deceit. The road geometry or environment is deceiving the driver, or has the potential to deceive the driver. And in this case, we're seeing a straight through, and we're seeing a run of power poles that continues through. We've got a run of lights that continues through. Okay. And there's even a run of trees that continues through. Those are all subconscious clues to a driver that their road continues unabated. There is like, okay, so we've put up some warning signs and some regulatory signs to try to tell them, hey, got to stop. But that avenue effect, the see-through effect for, it could be one in 100,000 drivers is enough that they shoot through. And it could be that they're very tired, they work a double shift. It could be foggy. It could be, well, actually, if it's foggy, they won't get too much of the see-through effect. But, they could be very tired. All sorts of reasons why one will. So that is, an influence. And we categorize intersection crashes into overshoot crashes or restart crashes. This is an overshoot crash in the sense that that driver has not recognized their obligation to give way until it's too late. So they've overshot the intersection. See-through effects are all about, they increase overshoot. Restart crashes are, we know there's an intersection, I've got to give way, and then a bad decision has been made. Either they've come to a stop and they've pulled out at the wrong time, or they've slowed down a bit and sight distance is no good, but they've decided to go, whatever it is. So then there's all these factors that may have influenced, and all of those things you're saying we could look at. We may report them in our audit if we think they're bad. We may come up with ways to rectify that. But then there's the crash that does happen, and the crash has happened. It's hit this light pole, and the light pole's broken away. Now, there's overshoot and restart categorized for you just in your notes. I've already explained those. But we saw the slip-based pole now. Okay, that light pole was designed to break away on impact, and that's about lessening the severity of the incident when it occurs. So slip-based poles are pretty cool. Like, they do an amazing job in terms of they break away when they're struck. Here's one that shot through a reassurance sign up there in New Plymouth, and the vehicles hit that at some decent speed to shoot it up through there, but there were no injuries. Like, that is phenomenal. If that was a rigid pole, death for sure, or serious injury, absolutely. Like, huge stuff. But if we can, make those decisions to make the pole frangible is the word we use, breakaway on impact, we can really address some of that severity. So there's good safe system in action. So as an auditor, you might be given designs that include decisions on light poles. Are they going to be rigid? Are they going to be slip-based? And you might see this sort of stuff, and you'd have to read into the details and work out, okay, they're using those poles. Or make sure you're with people in your audit team that can help you understand what they're going to build, and then you can ask logical questions. But if we were in this environment, we've got these light poles here, and we said, we're worried about vehicles leaving the road and hitting those. So what if we decided to make those slip-based, breakaway on impact? Could there be any other issues with that? Anybody pop that into the chat? We're here in an urban environment. I think this is during lockdown though, so it's actually quite quiet. Pedestrian strikes, absolutely. Well done there. And so some prizes can go out there. Pedestrian, we're thinking about where it will fall, and we're falling onto other road users. So rule of thumb is that high speed roads, you don't have these, you would use slip-based poles, okay? Low speed and these urban environments and pedestrians and lots of activity around, rigid poles, because the speed of vehicles should not be high enough to create that energy to the road user. And in between, there is another type of pole. It's called an impact absorbing pole. This is it. It's sort of crushes and contains everything within an envelope, so they can be done in your medium speed environments if you like. So on the left here, the video, it's an impact absorbing pole. It's probably a higher speed environment that I would use an impact absorbing pole. I think it's interesting, but it shows you how it works. It's sort of, it hasn't gone, it hasn't fallen onto the carriageway. It sort of folds back on itself there. Impact absorbing. On the right here, we're seeing a slip-based pole. So the whole thing will come out and come down, and you can see how that falls. So as an auditor, I mean, we will be looking, in a design, what are they going to use? Where's it going to fall? Is there danger for the occupants of vehicles? And then the existing roads or post-opening audits or the like, we'll be looking at things like the height. Okay, they've put a slip-based pole in. Is it the right height? If it's too high, vehicles are just going to snag on it. And if it's too low, it kind of just doesn't quite function the way we want. It's not as bad, but okay, so a safe system audit, it's defined in the safe system audit guidelines, which are on Wakatahi website, and we're putting them into the learning management system. But it is a formal, robust technical assessment of transport safety. So it's a risk assessment. It's done by independent and qualified teams. So you can't audit your own design. You can't audit the design that you're the project manager of. Right, and you have to be qualified. You have to have, done this course and have that qualification. It considers the safety of everybody. This is not just for cars, but it includes pedestrians, cyclists, motorcyclists, e-scooters, hoverboards, trucks, you name it. It's all safety of everybody. And we use safe system principles. And the last one I've highlighted there, I'm not going to read all of this, not a review of compliance with standards. But we can do these safe system audits at different stages along a project. You can do it at the early stages when it's a concept design, they're just starting to design things up, or they've got a bit more design, a bit more meat, preliminary. At the details stage, you can do this sort of process during roadworks, although there's some other stuff associated with that, and post-construction, so pre-opening or post-opening. I'm seeing a hand up there. I'm not sure we're going to have too much time here because I need to give Loretta time, but I'll let you work that out, Loretta. Maybe we can have a quick comment from Gareth. But as I run through this, well, actually,
Okay,
Gareth,
great. While you're going through there, just bring in safe systems professionals early in your project will pay dividends in prof services costs of changes later on. The earlier you get people involved, it actually saves you a lot of money, full stop. What
a wonderful comment. Thank you. The earlier, the better. And that's something that we will stress throughout this. The earlier, the better. Because once you're down here at detailed design, people just do not want to change, right? So earlier is better. So feasibility stage, big picture planning type projects, thinking about, land use stuff. How are people going to get from up here down here? Is this a good intersection form? Like, could we change things? Is this going to be confusing? Big picture stuff, right? Planning stuff. Then you get into preliminary. You've got a bit more detail, a bit more meat on it. Could be on a survey base, could be on an aerial base, and you're looking at, how this all functions and making choices. Then you get into detailed design. And we've got the long section, the cross sections. We've got the pavement plans, the signs and lines plans. We've got the signal phasing. Okay, this is big. Like, you sometimes get hundreds and hundreds of A3 pages to pour through, and you're looking at this and you're trying to work it out. You do this in a team. So if you're not somebody who can really understand what's going on in a plan like this, you make sure you're part of a team where there are people who can, and you can still ask really good questions and be contributing to the audit in saying like, oh, well, how are people going to get from over here to over here now? And these sorts of questions are great, but you do need that technical aspect to it as well. So you need people in your team who are, really technically astute in these sort of things. Pre-opening, before they cut the ribbon, checking everything, anything that can be done, that's where your roads, are at the stage where, there's no traffic on it. Most of the time we're dealing with a lot of brownfield sites, so they're kind of live to traffic anyway. And that's where you're in more post-opening stage audits where it's kind of live to traffic as they were building it. They managed it and they continued on. But here's an example of things you might pick up. We've got a left turn from this lane and we've got a straight here. That's not looking good. That, those sort of things do slip through the net sometimes, and we pick that up. And finally, there's things called thematic audits where you can have a dedicated cyclist or a motorcyclist, or you walk through it, or you go in a wheelchair through, or get somebody in a wheelchair to go through it, and you're really thinking about that specific road user. And we'll talk a little bit more about these later on. Okay, over to you, Loretta. Take them into the learning management system. Thank you for all the wonderful input, everybody. You're a really good group. Lots of interaction there. I'm going to give you an exercise on Friday where you'll be doing a little bit more work yourselves. But here's the learning management system. Over to you, Loretta.
Thank you. Can see my screen okay?
Yeah, looking good.
Great. All right. Well, the good news is about 99% of people have already logged into the system. So well done and thank you. I know a couple of people, or one person had an issue, so we'll sort that out. But yeah, once you log in, you can see the welcome page here. So basically just, I guess, scrolling down on the dashboard here, you can see you have to work your way through. There's 6 modules, 6 sessions. If you forget the link to the webinar, you can click in here and find the link. As I said, a lot of people have logged in and introduced themselves. If you haven't, please feel free to log in here and say hello to your fellow participants. A lot of the resources that Ken has or will make reference to throughout the sessions, you can find in here. So feel free to look through. There's a lot of fact sheets and guidelines, a lot of detailed sheets in here. So if you scroll in here, you can download those, download them all, or as you see fit. But the good news is module 1, we'll ease into it. So you can see the presentation. There is a video in here for you as well. But the only task to do for module 1 is a quiz. So nice and easy, ease into it. Once you click on here, you can click on attempt quiz now. Once you click in there, there's a series of questions that you do need to answer. So following through all the questions, there should be a Wally question in there too. Hopefully you kept track of how many Wallies you saw throughout the session. So submitting that quiz and just overall, ensuring that each module, you'll get access to each module as we go through, but making sure that you are, ticking them off the list, but each module you'll know what task there is to do. Did I miss anything there, Ken?
No, I think that's about it. Maybe click on the quiz. Sorry, did you click on the quiz?
I did.
Yeah, sorry, I missed.
That's all right.
No,
good,
that's
but
good.
nice and easy.
If you do have any trouble with the learning management system, get in contact. I will continue to drop different resources in there if we talk about something and I point at something else. So we've got that there. Make sure you have access to the learning management system. Now, a couple of minutes before next session officially starts, we'll be doing some trivia, asking some little questions, give out a few prizes. We're trying to incentivize you to make sure you log in on time. So feel free to jump in 3 minutes early. We'll give out some prizes and we'll then get going for the session, which is on Friday, I believe.
It is, yeah. So always the same time, but different dates. So hopefully you've got them all in your calendars. And thanks. What a great group with the interaction and lots of prizes that you've handed out. So that's great.
Thanks, everyone. Have a good day.
Thank you. Have a good day. Bye.
Bye.